Okay, and welcome to a tutorial on the launch version of the CFX rig for procedural anatomy. We're just going to go over a few things, mainly the changes that have happened to the CFX rig since the launch of procedural anatomy and the differences between that and the beta version. So we're going to go over linking characters in animation, naming schema, setting up character animations, and cache management options, and just the nodes in general, if there's any kind of specifics about that. And yeah, with that, let's get started. So the main example file we'll have here, we may not have some animation for you provided, but we can definitely link to animations in the Discord. That said, we do have the typical Tommy output here, and we'll provide this as a sample file as well. The animation of that was from the beta. You can see here, this has actually already been cached out. If you're wondering how we did that, you can just go in here and cache that. I use the hotkey Shift G. And while that's going, we can leave that running in the background. But we're going to the CFX rig right here. So starting with the anatomy rig load node, we are grabbing basically the exact same paths from the anatomy output, which is here, hip, geo, and then because this character's name is Tommy, as you can see, it's saved out to that. And just to find it here, we're using Tommy bgeo.sc from the version 1 folder. Now, by design, we have a character cache file. This is meant to not really be used for anything other than setting up the anatomy model. So you do have to pay attention to which one you're choosing. If we're going to our hip folder, we're going to look for geo, Tommy, the version 1 folder, and then Tommy inside of there. And that'll allow us to go to the animations next and set up our animation here. Now this is set to D projects and blah, blah, blah. It's set up to the right place, but we can go to hip animations, Tommy version 1, saunted lunge. I always recommend the hip, putting things in the hip folder. You know, the idea of procedural anatomy is to basically be a contained piece of tooling where, you know, we do all this in our own little space, and then you can export it wherever you need it to be. Now, the thing about this is there's two options you have here. Because of this text file, if you're doing only one character, this works perfectly fine. If you're doing multiple characters, what you have to actually do is take this, and I'll show you right here. You have to do backtick, just 2 of those, and then grab a channel string, CHS for channel string, and then we go back over here, and it is character name. So we can type in character name. You'll see character name 1 pop up. You don't want that version of it. You just want it without any numbers or letters or anything like that. The reason being is because when it goes through the character index, it'll always pop up here, and character 1 animation will always be here. Now, you don't have to do this if you're not using multiple characters. This is only for using multiple characters, and you're expected to have the same kind of animations all exported from the animation phase to the simulation stage. You only have to worry about those naming schemas in the animation side of things, not in the character side. I believe that you could actually switch these as well too to where the cache directory is. Cache directory, cache path, cache version, and the version padding. So we work on frames with procedural anatomy. We might give the option to use time in the future. It's just hard to support both at launch. So that's why we kind of went with frames as one choosing one or the other. But basically, this will create your output path for you. And we'll, again, come back to that later. The skeleton, the anatomy rig animskel to skel node, which is just horribly named, but works really well, is going to just show you your character's animation on the skeleton itself. And this is where you can just spot check and actually look at, is everything working? Is it moving as you would expect? Are there any problems arising? That's what it's mainly for. Now, if we go on to the anatomy rig, let's make that bigger. Anatomy rig animate muscle lines. It'll take a moment. The anatomy rig animate muscle lines is going to show you the flexing of the characters animation with their muscles. So anytime a muscle goes white, with a few exceptions, the iliotibial tract, anything like that, the yellow is something that's flexing. Even something red is maybe like a 25% or 50% flex. But you can see the dull red, the actual muscle color is basically unflexed right now. And there are some problems with this. We're only taking a direct linkage right now between the length of the muscle and not the pose of the character. So that is an issue. You know, you can have muscles like this that you expect to be flexed further. Like this is a pure white right now, so that's fully stretched. You would expect probably this to be fully white as well too, but that's something we're going to address in the future. In any case, though, moving forward with that, we can go back to the start frame. I always advise, if you're not really working or doing anything that requires you to be on a frame, go back to the start frame because it'll stop the solvers from calculating. This is basically the muscle simulation geometry that we use. And the reason it is set up like this is to basically go straight into the vellum solver. Now we use a vellum solver that you can, that comes automatically set up with the template. And the vellum solver is essentially the normal vellum solver. We don't modify it right now. We may in the future make our own, but it would only be to optimize this stage, the muscle stage, and then the, well, we don't even use it actually right now in the, after the rig tissue. But basically it's just to get this all into a package that is simple to use and, you know, wait for the simulation to go kind of thing. So I started up the simulation right here, but just to go back to the rig skel to muscle node, we are doing a lot of automated calculations. So if your character is in the right scale and size, which you will have problems if it's not, but if it's a human size, right now it's basically set up so you will work automatically without any changes to the simulation settings. The caveats for problems like floppy muscles or things like that usually end up being that the muscles need to be modified in the modeling stage. You can see right here, now we've done about 3 frames there, and we can stop that. Just go back to a frame that exists. Now, so this one doesn't have a problem with that, but usually, you know, if you have a floppy muscle or anything like that falling, generally there's like some problem with it. And we're not perfectly getting everything. You know, you can see sometimes, like this one went inside the leg right there. So that will need to be looked at and fixed if possible. But to get like a basic simulation out, we just basically get everything set up and then through the vellum solver. And then this is where the node that we cache everything. And this is very much a work in progress. The smoothing is important just for the end result look of the muscles, but it's a deformation, not a simulation for that. The loading and visualization is going to be a separate thing that hasn't been implemented yet. Right now, if you cache the tissue collision, it's automatically going to force it on if it exists, and that will basically display the end result of caching the system to that. Now, going back to our animation, that's where our simulation attributes live. on the specific animation. We have 4 different options here. And we'll just talk about the muscle simulation first and the tissue collision. The muscle simulation is actually the end result of the vellum solver. That is the exact vellum geometry that's coming out that we cache. We don't actually turn that on because it does not need to be cached if you're caching the tissue collision. And the reason for this is, again, that this is what you see in the vellum simulation. Only those geometries are going to be cached, right? The bones and the any other kind of meshes that we may add, like fat or anything like that. Actually, fat would be in this as well too. But the point is, you have to put it back on with the bones and rebuild that. So it's like a secondary step that we just do not need to cache. Both, because you're going to need the bones and the muscles to do the skin in the following stages. So this is something that we will be working on to get this to be a little bit better. It's basically going to show you what you're viewing and then try and drop it based off of what you're forcing it to do. We don't want to make it too complex to get a cache out, but the point of this system is essentially to get as many layers as quickly as possible. So this is a simplification that we're trying to make, and open to feedback on it if you have any opinion on it or anything like that. But once we have these muscles and bones cached out, so we can go into the skin part of the rig, and we'll head back to the first frame, and you can see that we're using the same kind of tissue generation after a moment here of just evaluating. And we split up the character into small triangles, basically, to triangulate the mesh, and use the entirety of the mesh as a place to create more detailed wrinkles and things like that. And depending on how much detail you have in your character, this may or may not match. And you should be aware that there is a kind of like almost a maximum size these should go, but the smaller they are, the better almost for the surface. That will give you more detail, and that's controlled. Everything actually dynamic is controlled in the anatomy muscles output and anatomy output. And if it's not there, we're going to be putting parameters to control that soon. Now, this just goes straight into the solve as its own. And I don't have any cache, unfortunately, I think, loaded. So it's just take a moment to do that. So I'm going to cache out a few frames. And because the automate network is set to have a null at the bottom at output, and the render flag is set to set on that one, we can go back up here and just hit cook output node and give it a few minutes to do its thing. We're only going to cook a few frames of this, so I'll come back when that is done. Okay, I just cached out a few frames, I think like 20 frames or so. And I just wanted to show an example of, sometimes this will error. The node doesn't actually have an error or something. It just, you exit and go back to the start frame. And this will error and, not allow you to middle mouse button click to check if the error is actually going to go away. It just continues to error. This is a dependency error that I'm not sure why it happens, but you can just basically go through here and clean that up inside of it. That said, the main thing is we don't actually have an error. It's worked perfectly fine for now. But we can go ahead and go to the rig tissue. And there's some problems with the sim, actually. I've noticed one muscle's like going flying off. Not too far out, but we're going to get that sorted as well too. Basically, it's kind of moved with the, or it's done a deformation based off the muscle simulation. And this is pretty good for right now. So we'll go ahead and just show you, going past that, the skin result. And I know it's Tommy and there's some problems, but basically this is how it's meant to work. The simulation reg just starts right after the tissue collision simulation. So it's deformation instead of that, and then you can get it out right here based on the output as well too of the first one or the skin in this second one here, and go to any other number of cache formats such as Lembic to get it to where you need like something like an Unreal or something like that. The save buttons here don't quite work yet. They were to simplify it, and we're still going to make those work, but it's basically just you should use the TOPS network instead. And I'd really recommend using TOPS because basically you can do a lot more with them than pressing the button on here. It's not 100% always as easy to understand what's going on with TOPS, but you can still just dirty all and cook output node and see where it gets to with everything in here. Yeah, with that, look forward to more detailed examples of this and setting up a character and doing the whole process on a new character and with better proportions and some different animation and everything like that in the future, because we're going to be doing some more of these tutorials just to make sure everybody understands how procedural anatomy works. Bye for now.